The James Webb Space Telescope, JWST, isn't just another telescope, it's the sharpest, most advanced window humanity has ever opened to the cosmos. With its golden mirrors and infrared eyes, Webb allows us to peel back the layers of the universe, revealing hidden details of distant worlds, stars, and galaxies. It's more than a scientific instrument, it's a time machine and a magnifying glass combined. Recently, Webb turned its attention toward one of the most talked about exoplanets ever found, K2-18b. Located roughly 120 light-years away in the constellation Leo, this world has sparked intense curiosity. At first, it seemed like just another faint dot orbiting a small star. But the more data scientists gathered, the stranger and more fascinating it became. The discovery that shocked astronomers, K2-18b showed signs of something extraordinary. Within its thick atmosphere, water vapor was detected, and along with it, methane, carbon dioxide, and hints of an even rarer compound, dimethyl sulfide, DMS. On Earth, DMS is almost entirely produced by living organisms, mostly by tiny plankton in the oceans. Its presence elsewhere raises a thrilling question. Could this distant world harbor life? To appreciate the magnitude of this discovery, we first need to understand what kind of planet K2-18b actually is. A world unlike any in our solar system, K2-18b is what scientists call a sub-Neptune, or, in other words, a super-Earth. It sits between rocky planets like Earth and gas giants like Neptune in both size and mass. Measuring about 2.6 times Earth's radius and nearly 9 times its mass, it doesn't resemble any world in our solar system. Its thick, hydrogen-rich atmosphere sets it apart from typical rocky planets. This atmosphere could act like a massive insulating blanket, trapping heat and possibly keeping temperatures within the range that allows liquid water, one of life's most essential ingredients, to exist. Despite orbiting extremely close to its parent star, just 0.18 astronomical units, far nearer than Mercury is to our Sun, K2-18b isn't an inferno. That's because its star, K2-18, is a red dwarf, a small, cool star that shines more dimly than our Sun. This delicate balance means the planet may be warm enough to host water, but not so hot that it becomes sterile and dry. How Webb peered into its atmosphere. When K2-18b passes in front of its star, starlight filters through the planet's atmosphere. During these transits, Webb's sensors analyze that filtered light. Each gas absorbs specific wavelengths, leaving behind a spectral fingerprint that scientists can read like a barcode. From this fingerprint, Webb detected the unmistakable signs of water vapor, methane, and possibly DMS. Methane can form through non-biological means, but it tends to break down quickly under radiation. To remain detectable, it must be replenished, and on Earth, that process is mostly biological. So, if DMS truly exists there, it could be the first whisper of alien biology. The possibility of Hycean worlds. But how could life exist under a dense, hydrogen-dominated atmosphere? That's where a fascinating new theory enters, the idea of Hycean worlds. In 2021, Dr. Nikku Madhusudan, an astrophysicist at the University of Cambridge, proposed that some sub-Neptune-type planets could host deep global oceans hidden beneath thick hydrogen layers. The term Hycean comes from combining hydrogen and ocean. These planets might sustain liquid oceans far below their clouds, shielded from stellar radiation and stable for billions of years. Microbial life could thrive in those oceans, feeding on minerals, releasing gases like methane or DMS, and shaping their atmospheres in detectable ways. If confirmed, K2-18b could be the first known Hycean world, and possibly the first sign that life exists beyond Earth. The new frontier in the search for life. Hycean worlds may hold the key to unlocking one of humanity's greatest mysteries, the existence of life beyond Earth. These exotic planets, cloaked in thick hydrogen atmospheres and possibly covered by vast global oceans, represent a completely new category of habitability. Unlike the rocky worlds we're used to, Hycean planets are larger, warmer, and more dynamic. Their size makes them easier to spot when they pass in front of their stars, and their extended atmospheres act like giant canvases for telescopes such as the James Webb Space Telescope to read. Every layer of gas leaves a chemical signature, a faint trace of what's happening beneath the clouds. Webb's ultra-sensitive instruments can separate that starlight into thousands of wavelengths, allowing scientists to detect molecules like water, methane, and possibly dimethyl sulfide, a potential byproduct of biological life. As our observational techniques improve, Hycean worlds are quickly becoming the prime candidates in the search for extraterrestrial life. They challenge the long-held belief that only Earth-like worlds, small, rocky, and oxygen-rich, could support biology. Yet, scientists remain cautious. The supposed detection of DMS in K2-18b's atmosphere is still under review. The signal could have alternative explanations, perhaps unknown chemical reactions, or even complex geological processes deep within the planet. Confirming life from light years away is extraordinarily difficult. Every reading must be double-checked, repeated, and validated using different methods and instruments. But if this signal endures, if DMS truly exists there, it could mark one of the most transformative discoveries in human history, the first evidence that life has taken root on another world. A new definition of habitability. For centuries, humanity's idea of a habitable planet has revolved around one blueprint: Earth. A blue world with oxygen, continents, and sunlight. But K2-18b might force us to rewrite the rules of life itself. If life exists under its thick hydrogen atmosphere, it means that the conditions for biology could be far more diverse than we ever imagined. Life may not need a clear blue sky or continents at all. It might flourish under heavy clouds, in oceans warmed not by sunlight but by trapped heat or geothermal energy. Picture this: a planet bathed in a dim red glow, orbiting a quiet, cool star. Its skies thick with mist and hydrogen haze. Far beneath, an endless ocean stretches into the darkness. Deep currents circulate minerals and warmth from the planet's core. Tiny microbes drift in those alien seas, consuming nutrients, releasing gases, invisible messengers that rise slowly through the atmosphere and escape into space. Across the vast gulf of 120 light-years, those gases, faint traces of methane and dimethyl sulfide, are caught by the mirror of a human-made telescope. And for the first time, our species realizes that the universe might not be silent after all. It's a profound shift in perspective. K2-18b teaches us that life could be universal, not restricted to carbon copies of Earth. Perhaps in the right conditions, chemistry naturally evolves toward biology, no matter what form it takes or what world it inhabits. And in that realization, the universe suddenly feels a little less empty. The bigger picture: K2-18b is only one world among trillions. Yet it stands as a symbol of discovery, a turning point in how we understand our place in the cosmos. For the first time, we are beginning to look beyond the familiar, beyond rocky planets and blue oceans, and to imagine life thriving in environments utterly unlike our own. The James Webb Space Telescope has made this possible. Its ability to capture light with such precision is allowing us to explore the atmospheres of distant worlds as if we were there ourselves. Each observation Webb makes brings us closer to answering that haunting question: are we alone in the universe? The answer still hides among the stars, but K2-18b gives us a reason to keep searching. It reminds us that discovery doesn't happen all at once. It happens step by step, signal by signal, across decades of patience and imagination. Future telescopes, even more powerful than Webb, are already being planned. They will study these alien atmospheres in greater detail, searching for unmistakable biosignatures and chemical patterns that can't be explained by geology alone. Someday, perhaps, we might even send robotic probes to nearby exoplanets, or develop technologies to capture direct images of alien oceans. If K2-18b truly harbors life, it would change everything. It would mean that biology is not a rare miracle confined to one small blue planet, but a natural process that fills the universe wherever conditions allow. It would connect us, in a very real sense, to a much larger web of existence. For now, the answer remains unknown. But discoveries like K2-18b give us something just as powerful: hope. Hope that life's story is bigger than we ever dreamed, and that our chapter is just one among many written across the stars. As our instruments grow sharper and our curiosity burns brighter, the search will continue. And perhaps one day, when the data finally confirms it, humanity will look up at the night sky and know for certain, we were never truly alone.